So folks, Alex here. So today I really want to start kind of a small series of videos where we will be trying to wrap our head around the notion of no STD programming, basically, right? And if you haven't heard of it, so this is like a crate level attribute that indicates that we will be linking against this core crate instead of STD crate, right? What does it mean though? So if you haven't heard of it, again, we have like several foundational crates in Rust, right? So alloc, core, proc macro, std, and test, right? And all the nice stuff, all the kind of usual prelude stuff, I would say, come directly from the std crate, right? So for example, printing stuff or std collections and like hash map and vector strings, all that kind of stuff, right? And many other stuff, like for example threading and thread synchronization and a lot of other stuff, right? So there is a clear distinction between this core crate and std crate. And why is that? So the reason for that is that for example printline, right? It depends on like implicitly depends on several stuff. For example, we have this notion of argument formatting, right? So it basically can take this kind of, a bunch of variables and that format string, and it should be able to print those somehow, right? Which means that like on low level, it would imply that maybe there is a kind of heap allocation somewhere, right? So we allocate some memory. We don't necessarily know how much memory we need, so that's why it's like a dynamic memory, and we kind of try to like pre-populate that memory with some kind of ASCII values or UTF-8 values for that matter, and then we need to like print that somehow. So we need to like copy that whole buffer into a kernel space and make the kernel print it and all that. So you already see that it kind of implicitly assumes a bunch of stuff about our execution environment, right? And of course, what's also interesting is that like all those facilities, they are oblivious about the platform that we are running in, right? So all the kind of implementation details are completely hidden from us, which is a huge W in kind of standard library design. But still, a lot of stuff, right? And the same thing for for collections, for example. But for collections, it's obvious that you need some kind of memory allocator. But also for something like hash map, you also need this random state. Um, Not random state, but you need some kind of way to kind of initialize your hasher with a random seed, because you want to prevent certain types of attacks on your hash map, right? And in order to do that, you need like an entropy source, and entropy source obviously comes from the platform. So all that depends on a lot of kind of implicit assumptions about your platform. That's why the core team basically like split stuff into several foundational crates, right? So std has like full niceness to it, but core doesn't do that. Core basically assumes nothing about your underlying platform, right? It just basically implements a bunch of like reasonably low level and reasonably useful algorithms, like that basically depend on the notion of memory and addressability and all that kind of stuff. And then yeah and basically what they say is that like with that bankno std, you will be getting only the core crate, not the std crate, which is interesting. So I still want to do some programming, like decent programming, maybe like write some relatively useful programs using just that core thingy. So let's see how it goes. Obviously, the like actual reason why would people use no STD is not that. It's more like when you're doing like very low level programming, like OS kernel programming or some kind of like embedded programming or something like that. You don't get any STD features. You don't even get a C standard library, right? And let alone the Rust's standard library. So that's why you would actually use it. But we will be using our main Linux machine. We will be doing just a normal user line code on that Linux. I just want to see like how painful that actually is, and like how painful it is to write any like useful code in that. So let's go ahead and see how it works. So I've already pre-made like a little project for us, like no std fun, right? And what we have here is basically just very normal standard way of doing like hello world, right? So let's see what gonna happen if I do this. I kind of just no std. So I'm saying, well, no std, and actually, you know what, I want no main as well. And it immediately says, well, I cannot find this print line thingy. So you can't do that. No print line, no print, no nothing, right? You can't really do that anymore. So what can I do? Also, what's interesting is that I've added this no main attribute, which basically says don't try to generate a kind of libc's libc's flavored main function, right? So the actual kind of entry point on Linux, at least, is this underscore start symbol, right? So basically, linker links your program in such a way that when the kernel loads your binary, it will so basically it will set up the control flow in such a way that it will start from that underscore start symbol, right? And the way it works with C is that it will start from that underscore start, and it will also do a bunch of preparation so that something like int main, int argc, and then char argv, something like that could be possible, right? And it's not possible by default, and we will see how it works. So I don't know. So let's see. Basically, what I want to do, I want to like get us back into that hello world example, and like get it at least rewritten in that kind of scenario. So let's see if that thing even compiles at all. So cargo check. What do you want from me? Okay, so cargo check. And it says, well, blah, 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 panic abort. Yeah, okay, and we are lacking a panic handler. Okay, so let's add panic handler, panic info or something like that, core panic info, right? And it returns nothing, and it loops forever. And I think it should be panic, no, not that. It should be like panic handler, something like that. And it says found a duplicate, and this is because by default we also get this tests crate, right? And tests crate has its own panic handler in order to catch unwindings and all that, and turn those into kind of nice error messages, right? So we need to say that this is only true when we are not in test, right? In panic info, I think it should actually be this, and let's see if it compiles. So it doesn't, right? Use nightly alarm, panic aborts. Since the code library usually precompiled with unwind, you should disable it. Okay, so let's see. Profile release, right? Panic abort, and release dev panic abort. Okay, so let's see. Okay, so it compiles at least. Whether it runs, no, I don't think so. And it doesn't run, so now it fails at runtime, and it fails at runtime because it tries to like pass the control flow to that double underscore libc start main, and we're not using C standard library anymore. We are in that main no std world. And I think in order to support that, we need Rust flags, something like -c, link arc equal to no start files. I think it's like that, which basically says, well, don't try to like link against like crt.o or something like that. Like make it super duper raw, basically make it static completely. And yes, so now it compiles, it runs, but it immediately, like we are immediately hitting that segmentation fault error, right? I think what's interesting is that, let's see, like file, target, debug, no std fun. I think like LDD, let's do LDD. So yeah, LDD says that now it's statically linked. So whatever we have here, it's actually statically linked. No standard library, no nothing, right? It's just a nice little piece of binary, right? Awesome. And let me redo this a little bit. So I want to keep stuff here, something like hello world rs, right? And now I want to put it here, actually. Oh, come on. Something like that, right? Main, we don't really need that main anymore. So, okay, so run bin hello world, right? So segfault. All right, so how do we print stuff? In order to print stuff in that no std world, we will be needing to reach to the kernel directly for that, right? So Linux syscall table, right? Searchable syscall table, and we will be needing to do the write call, right? So write function sys write, and the way it works, it takes this file descriptor, constant pointer to a buffer and a size, and it will just print it for you. Not necessarily print it, but it will write to that file descriptor, and the file, if the file descriptor is 1 std out, it will print it for you, right? So fd, I think it can be usize. Buffer is a const pointer to a u8, and size is usize, and the result is usize. And the result is basically how many bytes been you know, written to that fd. And yeah, so how do we call it? So core arch assembly, right? So we will be calling into assembly syscall, and let's put, or how it's done, it's actually like this, rux. So the syscall that should go into rux is 1, right? So 1 RDI resi. So RDI is fd. RSI is that constant buffer. Then RDX is size. RDX size. And I think we also need to make sure that compiler understands that the RCX register is being thrashed as a result of that operation, and R11 register as well. And we also need the output of that. So I don't know, bytes written or something like that. And this is like your size, right? And late out, I guess, like rux, bytes written, and it's supposed to be mute, I think. And let's return the bytes written like that. And this is, of course, unsafe. Cool. So we have this sysread, and I'm not sure, but I want to do no mangle attribute on it as well. because why not? Cool, so let's go ahead and try, you know what, I want like a little abstraction on it, so something like function, like print string, right? So that would be like value, str, usize back, and we'll basically utilize this, so fd will be 1, because we're printing, right? Buffer is like value ptr, and this is like value len, right? So len is indeed a size in bytes, so this is what we want. So let's see if it works. So print string hello world /n, and let's see if it works. It doesn't still. Print string syscall, and I think that it doesn't work because we need to mangle that as well. Yeah. So hello world, right? So it prints hello world, but then it kind of segfaults nonetheless. And the reason why it segfaults is probably because it tries to kind of interpret the memory after that start symbol and after that, you know, print syscall invocation as code, right? And basically, you know, probably it like finds some kind of memory dereference or something like that, like a pointer dereference or something like that, and basically segfaults on it, right? So we need to implement a like an explicit exit function, right? And what's good about Linux is that it provides us with that. So there is an exit syscall, right? So exit syscall 60, and in RDI we can put the exit code, right? So function sysexit, and then like the code usize, I think it doesn't return, right? Because it's exit, and core arch ism. So syscall, and then in rocks should be 60, and in RDI should be whatever code we are fancy with. So RDI code, this is safe. That thing doesn't return, so and this is like unreachable, right? This is exit, and that thing doesn't return as well. This is exit 0, right? So let's see if it works. So before that we were segfaulting on the exit, and now we are not, right? So I can print hello world, and I don't segfault after that. Like, go figure. Cool, right? And we can see that. So let's run it, and let's echo the kind of last exit code, which is 0. This is what we are returning here. And if I sysexit 100, we run it, and you know, we are getting that 100 as a recent exit code. So this indeed works, what I'm trying to say. Cool. This is a good start. What I would really like to add to this is some kind of ability to print like usize number, right? And unfortunately, like, there is no way for me to say something like, I don't know, like usize, right? And basically just say like value, right? It just doesn't work like that. See, hello world value. And I really want, maybe not necessarily even that, but I really want to be able to like print the number at all. For those of you who are like very familiar with the core crate, there is a way to ask core to like format your stuff and print it. But I want to kind of implement it myself, at least like printing for the usize numbers, you know, for fun basically. So let's go ahead and figure out how to print usize numbers, right? So render usize. And what do we need by printing usize? Basically, we need some kind of utility that takes this usize number, takes a kind of, I don't know, buffer, like mutable buffer to U8 of U8s, right? And basically somehow like renders that usize number as a bunch of characters into that buffer, right? Because like at the end of the day, we will be needing to call this syswrite on it, and syswrite, the only thing it knows about is like, you know, constant pointers to U8 and size. That's it. So, I mean, let's see how that could have been implemented. So basically, as a result of that thing, I want my number to be rendered as hex, right? So something like, I don't know, 15 should be turned into this, really, right? And we should support that for any usize number. So let's say I have like a like offset or something, which is of course mutable. We'll be modifying it, and it should be something like buffer len like -1 or something like that. And I want that offset to kind of point to the end of that buffer, right? And I want to start kind of, you know, probing that number 4 bits at a time, right? And map those, like each chunk of 4 bits into kind of a letter that represents it, right? So what I mean here is that we have like digits, right? And all the digits we know of is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? And if like value is 0, right? I want to write to that buffer what? Buffer like offset, I want to write like a 0 as U8, right? And I want that offset to basically decrement, right? And then, yeah, and as a result of that whole shenanigan, of course, I should be getting something like buffer offset +1 and onwards, like that, right? So if the value is 0, we just basically do this, something like while value greater than 0, something like that. Let's create a new digit, right? So digit will be something like value something like that, right? So 0xf is basically 4 zeros at a time, right? So it's like a nibble full of so these are not zeros, these are ones, right? So these are 4 bits, and each bit is basically 1. And when we binary add our value with that thing, we're basically probing the leading 4 bits of that value, right? And erasing everything out of it, right? So we're taking this kind of digit like index, right? And the actual digit then will be like digits using this, you know, digit index, really, right? And then when we have that, we can do like value, we can shift it 4 bits, and we can decrement the offset, really. And the value should be mutable, of course, for that, right? Digit, and let's store that. So buffer offset equals to digit as U8, right? And this could be just that, right? So that could be just that. And digit could be just value and 0xf, so something like that. So value shift, offset, and at the end, as I said, I want that kind of look, right? That kind of look. So when we are finished with rendering the actual number, I want this, you know, OX to be, you know, added to the kind of start of that string, to the start, right? So it should be like buffer offset. So the first thing should be x as u8, and the other thing should be 0, and there gotta be offset decrement in between, right? Something like that. So this is render usize. So basically, again, it takes num angle. It takes this value, it takes the buffer, and it populates that buffer with the rendering of that value, right? So I want to abstract over it. So function, I don't know, like print usize, something like value usize. And as a result, I probably want, I don't really want much, right? Or do I? I don't know. Let buffer something like 0, u8, let's say with length 20. The buffer is of course mutable, and we are rendering usize value with that buffer. Rendered portion, and we do syswrite fd1 rendered portion as ptr, and size is rendered portion len, right? Okay, yeah, we can return new size, I guess. All right. So let's go ahead and test that out. So instead of doing that, let's just say for value in 0 to 100 or something, and print line, or no, print string, something like that, something like that, and print usize value. Yeah, let's see if it works. And it doesn't want to work because it's still trying to link against this memset symbol, and memset is basically a standard C standard library function that fills memory with a constant byte, right? I'm not sure why it tries to link against libc, but what it does. That's what it does. So let's just implement that symbol in pure Rust, and you know, just forget about it. So function mem set, what is the signature? So pointer, value, and size, right? So like buffer is a you know, const u8, value is u8, and the size is usize, I guess, and as a result it should give you const pointer to u8 again, right? And let offset is equal to 0 usize, and then while offset less than size, right, we kinda take this buffer, we kinda, you know, we kinda add the offset, right, with the reference, and we kinda just set it to be value and offset increment, right? And as a result of it, we should get the buffer back. Why? Well, that's that's what it asks for. So unsafe, unsafe, please, and then just put it here. Const pointer dereference, buffer, yeah, buffer needs to be mute pointer, And cannot assign to mutable, mute, of course. Yes, thank you. You are so helpful. No mangle. And I think it should be extern C. Just make sure that, you know, the ABI is here. So, and look, we are not even using this thing, right? We just defined it, but it should be enough actually. So undefined reference to Rust EH personality. So it's not unhappy about memset at least, right? So let's see Rust's EH personality used to by the failure mechanism of the compiler. This one mapped to GCC's personality function, but crates which do not trigger panic can be assured that this function is never called. So blah blah blah. Sure. So we basically need this as a empty function, really, kinda. So it does nothing really. So no mangle and. I'm not sure if we need that, but still. Okay, does it work? Yeah, I think it does. So basically what we are doing, we are printing all the numbers from 0 to 100, right? And in fact, you know, 0, 1, 2, 3, 9, A, B, C, D, E, F, then 10, 11, blah, blah, blah. So this seems to be fine, and 63 is 99 in decimal, so this works. Also, let's go ahead and try something like usize max minus 10, usize max or something. Just make sure that it works on that end as well. Yeah, it does, right? So FE, and the next one will be FF, and so yeah, I think if we do this, the very last thing would be FF, and the very next thing would be all zeros, right? So yeah, this looks good. This looks good. Okay, so I'm content with that. The other thing I'm interested in is reading argc and argv, right? So argc, or I rather call it argv, I guess. Argv, right? So question, right? How do we get, so in C we have this, right? Int main and like int argc char argv, right? We have this, but how do we get those at all? Because it doesn't look like our start function accepts any arguments at all, right? And we can't just, you know, implement it here. I can't just say, you know, argc like usize or something like that. That's not how it works, right? No one provides it here. So the way it works is that, at least on Linux, when the operating system starts your program, right? So it, as I said, it will pass the control flow to that start symbol, right? And it will like arrange your stack in such a way that RSP stack pointer will be pointing to the argc, and RSP plus 8 will be pointing to the first item of that star array, basically, right? Which means that if we wanna do what we are planning to do, like print argc argv and then utilize that and implement like a cat utility on top of it, we need something beyond that, beyond what we have right now. So I want to say something like, I don't know, function, let's call it entry. I'm tempted to call it main, but I don't want any confusion whatsoever. So I want that to be this, right? And like argc, like usize, right? And argv is like a const pointer to a const pointer to u8. That thing never returns actually, right? And what it does is this. But as I said, our actual entry point is the start, right? Which means that we actually need to write a bit of assembly here. So something like core core arch naked assembly. And the naked assembly is basically a flavor of assembly where the compiler would not generate, like if it sees that, right, it would not generate the preamble for that function. So it would not mess up the stack, which actually what we want, right? So let's try to do this. So naked assembly, right? Let's see what we have here. Like that. That is, of course, although it's not unsafe even. Use unstable library. Let's do Rust toolchain toml and toolchain channel nightly argv, right? I need to restart my Rust analyzer, of course. Okay, macro can only be used with function with unsafe naked. Okay, so unsafe naked, and it should be a CABI, right? So extern C, oops. Okay, so this looks good. And here, as I said, we are getting argc in RSP, right? So mov RSI RSP, right? And then RDI RSP +8, and then we'll just JMP to entry, you know, to that thing. And let's try to maybe like print usize argc print string I don't know, like argc and print string /n. So I just wanna print that argc value here and just see if it works at all. So bin hello world, that would be argv now, and it says argc is whatever number, which is not correct. So argc print usize RSI RDI RSP +8. Is it? I think it might be. Oh yeah, extern C as well, right? Because we need the compiler to generate that function in machine code in such a way that the CABI is conserved. So let's see. argc is still incorrect. Oh, interesting. So argc RSI, yeah, I think the first argument should go to RSI, right? Searchable. Oh no, it's RDI RSI actually. Go figure. RSI. Yeah, so now it works. So if I do this, yes. So that program that being invoked with 5 arguments says argc is 6, and this is because, you know, the zeros argument is the name of the program itself. So let's go ahead and try to print that all out, right? How would I do this? So let's argument counter something like that, 0 usize, right? While argument counter less than argc. And what we are trying to do here is that, you know, now I have this argv, which is, you know, constant pointer to a constant pointer to u8, right? And basically it's like an array of null terminated strings, right? And the problem is that, like, if I want to like print those, right, I need to know the lengths of those strings, and I don't know the lengths, right? So what I have is just a pointer, and I know that, you know, like whatever data comes like behind that pointer, it needs to be terminated with the 0, right? So basically, like for each argument, I need to figure out the len of that string first. So let mute offset or something, 0, use size as well. And yeah, while okay, so interesting. So while something like argv add argument counter, so we need to turn that into this. So now it's like add offset, and we need to dereference that like 0. We will be incrementing the offset, right? And then when we have that, we can actually try to print the argument, right? The string itself. So let's go ahead and do something like, I don't know. You know what? So like print use size. I want to print argc here. I want to print like string, like I don't know, something like argc, something like that, right? Then I want to print this. Then for each of these guys, I want to do like argv add argument counter, right? So I want to dereference that. And I want to kind of print string with 1, this, and like offsets. And print string, no, that should be like sys right? Cool. And argument counter, and after that we will increment the argument counter, something like that, and it should be mutable, and offset is mutable. That's good, that's good. And of course this whole shenanigan is horribly unsafe. So let's see. Oh yeah, and we need like a /n in between, right? So argv add, right? You know what? I want something like print use size, offset, and then print string, maybe something like this, then print this and print that. How about that? So now we're talking, right? Although I'm not sure what's up with that. Argc, print your size, argc. Oh, but why is that? Why it's 11? 1, 2. Interesting. Debug argv. Interesting. Wait, argc. Do we modify argc anywhere? Oh no, wait. This is weird. Yeah. Okay. So anyways, we're printing this, right? So argv 1, 2, 3, 4. The zeros, it should say 0, although it says 1, 1. I'm not sure what's up with that. So argc 5, this is correct. And notice this, argument counter. argument counter at offset, which is 0. And then we are modifying the offset +1. Print offset. Oh, I get it. We are not printing offsets. Yeah, should be argument counter, of course. That's weird why I'm doing this. 0, 1, 2, 3, 4. Okay, now it works. So argc is 5. And should I do something like, I don't know, like full bar minus n tar or something, I'm getting it correctly. So it does work. Look, mom, I'm programmer. Yeah, this is so stupid. Okay, all right, so this works, and this basically paves the way for implementing the cat program, right? So let's go ahead and take this, and I want that to be like cat, right? And please, like, close everything. I'm not sure, like, VS Code sometimes acts weird. So cat, for cat, we will be needing 2 additional things, right? So we have this read syscall, right? Read, which kind of very much like write, but it reads instead of writes. And also open, right? Ooh, flags and mode and all that, interesting. And also like close, right? Okay, so let's go ahead and implement a bunch of these. So syswrite. Basically we need something like that, but with sysread. So buffer, mute, do we have size? Read. Yeah, buffer and yes, size as well. And the syscall number is 0, fd, yes, fd char buffer size that, and bytes read. So bytes read, and bytes read. Cool. And this is c's read. Okay. So this is good. Then open, right? Open. So open kind of simple. So we have like sys open. So it has this kind of file name as a const char, as a const u8 basically, right? Also it has flags and mode. Flags and mode. I think that we won't be needing actually those, and the result should be I size. Oh, Vim, what are you doing, dude? Fd I size, and we are returning this fd, right? So syscall number is 2, right? Syscall number is 2. Flags and mode. Okay, so mon to open. Flags. What the fuck the flags are? The full list of file creation flags. Okay, file creation flags. We don't need those because we are not creating the file, right? So technically you should be good. So rocks. Well, fd, no. So RDI is what? RDI is file name. Then our flags and mode. I think flags are 0 actually. And what is mode? Mode T, mode. Append, create directory, mode, create trunk, read only. Oh, it's like writing. So truncate, read write. Interesting. Oh, actually, huh. Yeah, since we're not... Oh, I see, I see. So I think mode is basically like a mode of creation, right? So basically I think it's -1 and this one is 0, right? And this is fd. I'm still not sure about this, but let's see. I don't know. Let's try to create, let's try to kind of sys open, and as file name let's do something like home workspace, no std fun, right? So this is what it's called, and maybe like cargo toml, something like that. Let fd. Oh yeah, and gotta be a pointer, so as ptr, and print usize fd, and as usize, let's say. Okay, then cat. Yeah, and it returns -2, right? So home magnif workspace, no std fun, but you know, this is definitely something that exists, right? Workspace, no std fun, cargo toml. Yes, this is something that definitely exists. So I think what's happening here is that those flags are open. Those flags are incorrect. Okay, let's see. File name RSI, RDI. RSI flags. Specified, it may optionally or create specified flags and open, and flags, file flags, the full list of file creation flags and file status. And if we're not opening it for creation, path, interesting. Linux open for reading flag. Okay, uses read-only flag to specify that the file should be opened for reading. Okay, what is the read-only flag then? Rep -ri user include, and read-only flag is 0. So this is correct. RSI and reading flag and modes. Nesby pass flags, open syscall. And set to 0. Okay. That's still -2. Basically it says no entry. Homogeneous workspace, no std fun, cargo toml. But it is. What the hell? Why it's -2 and -2. I think -2 is no entry. Print your size. Oh wait, are you telling me that it needs to be this? Oh my god, it needs to be zero-ended. Oh, I figured it out. Turns out it needs to be null terminated string, because of course. All right, so our sysopen works actually, so go figure. And having that said, we should be able to Linux syscall table, right? Should be able to read it and also close it, right? So close, yeah, basically close is exactly like open, but close. So sys close, and it takes fd actually, which is u size, right? And fd, and it doesn't return anything. Right, so this is fd. This is like that, and then like that, and it doesn't return. And the syscall number is 3. Cool. Now, I think now we have basically everything we need. So we can kind of return here. Now, cool. Let's go ahead and create. So our task here will be to kind of cat stuff, right? So we need to like start reading the stuff and printing what we have so far. So let's see, print usize, la. Okay, so let mute read so far equals let like file name, let's say. So that will be argv, right? I think we should start from 1 argv add argument counter, right? So we just take that, we say, well, here's my fd, this is open, so this is that. If fd is less than 0, we'll just sys write to fd, let's say 2. We will let can't read the file. Message len, and this is as pointer, and like that. This is unsafe, but this is open. Yes, thank you. Okay, so we opened that. We kinda want to close it at the end, so sys close fd, right? And then do we want to continue here? Yeah, I think so. As usize, right? And the bytes read so far, so sys read from that fd, let like inner buffer, something like that. Let's allocate, let's say 10 pages, right? So for 96 times 10, right? It's a mute buffer. Okay, so we've read something. Bytes read or something. So while bytes read greater than 0, we will take the buffer, which is inner buffer actually, and inner buffer len, right? Let's read as pointer, okay. As pointer, wait, FDU size, okay, and this is, I think, and types don't match, buffer, okay, it's mute pointer, okay, mute pointer, like that. So while bytes read is greater than 0, we can print it back. So sys write fd1, this, you know, inner buffer, and bytes read, right? And then we kind of reread that value. And okay, as ptr bytes read. Thank you. Yeah, Rust is a very nice language in that regard. It just does what it needs to do. And we are closing at the end. So this should act like, and yes, it says, well, it doesn't need to be mutable. And this is because I forgot to do this. Again, it just saves so much time on debug, to be honest. This is so good. Okay, so yeah, we don't even need that, honestly, right? Cool. Okay, I think this is good. So I think what I could have done is like, yeah, bin cat or magnev, like workspace, no std fun, cargo toml, right? And it does work. So it prints stuff. We don't need to print this. We don't, right? We don't need to print any of that. We don't need to print to do that. Toml and cargo log or something like that. All right, so it works. So we've printed cargo toml and cargo log at the same time. And if I did something like hello world or something, oh, it does work. Oh, okay. So I see. So here, this needs to happen as well. Argument counter. Cool. Can't read the file. Yeah, so this is what we want, basically. So syswrite, sysread, sysopen, sysexit, print string. So values is write to, right? So here, this is write like error string. And yeah, let's keep it like this. Okay, it would have been great to like see the file name here, but I already removed the ability to have a len of that string. All that I can get it back, I guess. Let's do this. Can yes, can't read the file. And sys write, I guess, So the FD would be 2, and buffer will be argv add argument counter, like that, and then offsets and our string. Oops. Argument counter +1, and with this you can treat the file hello world. So with incorrect file, it now prints a correct error message, and I think we can actually do this, right? With correct files, it works as well. If I mix in something like correct and incorrect, it does it correctly, right? So that stuff is being printed to the standard output, and that thing is being printed to the standard error, exactly as we want. All right, so I think, you know, that's good for now. So at the end, we have everything we kind of planned for today, right? So we have a bunch of unsafe code, we have like no STD code, and we've managed to create this little kind of clone of the core utils cat utility, which cats files, and it even has, you know, some error checking capabilities to it. So I think it's good. So I hope you guys learned something. I will publish that code, and we will get more interesting programs, you know, on the next session. So I'm planning to do like an HTTP server. I'm planning to do something like memory managers, right? So we will try to implement our own malloc and maybe like use it somewhere. So stuff like that. And if you guys are interested in that kind of stuff, you know, you can stick to that channel and thumbs up, subscribe, that kind of stuff. And I'll see you on the next one. See you guys.